Hi everyone, welcome back to the Civrays InMoov. As promised, we're going to be looking at the right shoulder this time. We're going to be getting this module you can see here built up to this stage. We've got the gears inside and the ball bearings and grease all done. We've got the potentiometer installed. I'm not convinced that the potentiometer is set up in the right position, but it is installed and it is working. We'll have another video in about 2 weeks' time where we'll finish off this right shoulder assembly, but we may not be installing it into the robot for a little bit more time yet. So I'll get into this and I'll show you how I built this module up to this stage. So I did a lot of the preparation off camera before we started today because I didn't want to bore you with all the sanding and filing. Basically I just filed around this piece a little bit. And mainly the work was on the actual worm gear itself, just making sure the worm gear is completely smooth. I did file around the top of this bit a bit, the sides of this top piece, just to make sure that fits quite loosely down into that groove down in there. And I think this is fitting quite nicely in there now. I can easily rotate it by hand whilst it's in there. So I'm happy with that. The point I'm trying to make is you just want to get all the sanding and filing out of the way, get everything clean before we start applying grease, because once we put grease on this, we definitely don't want to be doing any sanding. The other piece I did have to pay a bit of attention to is this top section that goes on afterwards. If we just pop the worm gear down in there. In here in this piece, I always find this isn't recessed enough, so it's difficult to file, so I kind of just scrape away at it to get it a little lower. And what I did do is just knock the corners off of this edge here and this edge here, just so that the worm gear has just a little bit more room on these edges here and this side here, and with the worm gear in place with the lid on, I normally find when I first put these together you get a bit of a gap down here, and the worry is that once we put the bolt in there and it sort of tightens up, we'll be putting too much pressure on the worm gear and we won't be able to rotate it. So I just sort of did a bit of work on that, opening this up a little bit. Filed this out a little bit here as well, just make sure that everything is a nice fit so that when we tighten that down we can still rotate the worm gear. It's a little tighter with the lid on. I'm hoping with some grease in there, a bit more torque from the servo, that will turn okay. So I think that's all good. We can start putting that together now. So the first thing we're going to do is attach the servo horn onto the worm gear. I'm going to be using these number 4 screws. They're countersunk, so we want to keep the heads as low as possible because we know that we have a clearance issue with the heads. So I'm going to open up these holes here, just make those a little bit bigger, and I'm also going to try and countersink the plastic so that the head of the screw will recess down into it a little bit. So that was 2.5mm. I think we can go even bigger. Let's just see what that's like. So the thread's gripping into that, but it should be a clearance hole. So I believe these screws are 2.9mm threads. I think that's the number 4 thread. So if we open it up to 3mm, that should give us a clearance hole. It's always best to start small and gradually open the hole up. Makes it easier to drill and you're less likely to crack the plastic. So they should just fall through now, yeah. But you can see the head doesn't recess in, it still sticks out quite a lot. So we want to try and countersink it. It's a bit too tight to get a countersink bit in there, so I tend to just use a larger drill bit. It's really quite difficult. It's a 5mm drill bit. I think that'll just clear that. It's still a little too big. I'll give it a go though. Going really careful because it wants to bite into the plastic and it'll just tear it up. Probably better if your drill bit's a little bit blunt. Okay, let's have a look. So they're not fully recessed in. We probably could try and countersink them a little more. Let's have a look at a different one. Yeah, I think we can go a little bit more than that yet. That's the problem, the drill wants to bite into it and go right through. Okay, I think that's as much as I dare go on that. So normally there's numbers on there, I don't know if you can read them. Might be a little tricky to see on the camera. You have to trust me, there's numbers on there. I tend to find the odd numbers are the ones that line up. So I didn't drill the black servo horn at all. Number 4 threads seem to be the right size. Tap straight into that. That one one's really sunk down in there. It's just deformed the side a little bit. We can probably clean that up with a file. So I'll try and show you how much the head's sticking out. Hardly anything at all. In an ideal world they'll be fully recessed, but it's a little hard to get the countersink in the plastic. I think that'll do. I think one of them might be a little proud, maybe this one here. The other three look fairly low. This one's probably the highest. Okay, I think that'll be fine. So the other important thing about this is that the remainder of the screw that pokes through the other side needs to be completely cut off and filed flat, because there's no clearance down here. So as that rotates, if we didn't cut the screws off, they would catch at this point. Now I've popped that in there and I think it's rotating fairly freely. There is just one screw head that seems to be just ever so slightly catching, so I might just give that a little quick file. I think one of them I sunk in a little bit deeper than the rest and it's sort of pushed the side out a bit, so I'll see if I can correct that. Yeah, so I'll give them that another little file, and that, I think that's as good as we're going to get that. So we'll bring in the servo now. That can just push on here. Now I've already modified these servos, so the potentiometer has been removed, and I've soldered this extension cable on where the potentiometer was attached so that we can mount that remotely, and I also snipped off the stop in the gear so that we can have continuous rotation. I didn't want to bore you with that process. We've covered that several times now. There was another 2 to do on this shoulder, so I've gone ahead and done them. I did just run a 2.5mm drill through these holes. This should be able to plug onto here now. So I'm using number 6 by 1/2 inch screws. I think that's 2.9mm by 13mm. You should hopefully screw in there. Going really slowly because they feel quite tight and I don't want to crack the plastic. I'm not going to super tighten them. Okay, I think it would be wise to just try this before we start putting grease in here. So I've just got it hooked up to an Arduino, and it's just sweeping backwards and forwards. It seems quite smooth. There's a small creaking sound. I think that's just the way the plastic rubs against another piece of plastic, so grease normally solves that. I think that's good enough to continue. And hopefully you can see I've got the potentiometer connected up. This is just on an extension cable, so I can plug that in there. That gives us a lot of length on that. We can always shorten it later if we find we've got too much, but I like having the plug in the middle because it allows us to disconnect it should we need to. I've actually got the Arduino commanding the servo to position 90, which is the center, and I've got the potentiometer pointing straight up, which is in the center position, so the servo is currently stopped. If I just gently turn this one way, see the servo start to move in one direction. I pull it back to the center position, it should stop. And then if I move it the other way, the servo rotates in the opposite direction. Back to center, it should stop. Now, I've soldered this potentiometer on here, and I've just insulated the middle pin. There's two reasons why I've done that. We want to make sure they don't touch. The outer two can't touch each other because they're not near each other, so we only need to insulate the center pin. However, we may need to reverse these two outer ones, so by not insulating it now, I can quite easily unsolder these and reverse their positions if I need to. And then whilst we're discussing the potentiometer, we actually have the potentiometer holder here. This is straight off the printer, still got the brim attached. Our square potentiometer fits in here, and then this round part fits into here. That allows us to rotate it even though it is square. So it kind of converts the square to round so that we can rotate. And I think the reason why we may possibly need to rotate it so that we could just make fine adjustments. If I just remove the brim, so you should see that part needs to fit in there. I'll clean these parts up. We need to clean this brim off properly. So there, I've cleaned them up. Just pushed this dovetail joint down in there. After just cleaning the part up, it actually pushed in there quite nicely. And then the round part is now sitting in here. We can see that that will rotate. So I thought this time I'd try something a little bit different. I've bought some of these square M3 nuts. So they're 5.5 millimeters across from one side to another. That's the standard size for M3 nuts, but they're in a square shape rather than a hexagon. I thought I'd see if they fit down into these little slots down in there a little bit easier. So let's give that a go. So they do fit very easily across the width, but as you can see, hopefully, there, that still isn't going in enough. So the hole's not going to line up. It needs to be pushed in further. Now, somebody suggested heating them up and then pushing them in, which I'm sure that would work, but the experience I've had with heating this plastic is it melts very quickly. And I don't want to deform the outside, this nice curve here. I want that to be nice and smooth, so I don't want to mess that up. So I think what I'm going to do is I am just going to grind these nuts down a little bit with the Dremel. I'm just going to knock off two of the corners So I've got the first one in there, went in there quite easily after grinding it. I'll just show you the second one just before I pop it in. So we started off with a square nut, and I've just sort of ground one side of it away. So hopefully that makes sense. I'll pop that one in. So then the next thing to do is to get the nuts into here. And we will use hexagon nuts for those, because that's what they're designed for. First thing I'm going to do is just run a drill through here at 3mm, just to make sure that hole is clear. And then we'll fit a little bolt through there with a washer. Put the nut on the other side, and then we'll just give it a little bit of heat and then tighten it up. So just do them up so they start to go into the hole. So they're kind of lined up with the hexagon hole in there. I put the washer on this side so that just spreads the stress so we don't sink the head of the bolt into the plastic. We just want a real gentle heat. So they do feel quite tight, so I'm not going to overdo them. It has just, that one has almost sunk all the way in. I tried to push down with my thumb on the top of the part as I tighten it, otherwise the plastic is soft now and it raises up. You can always give it a file off if you do end up with a lump on the top. This one's just been a little bit more awkward. Sorry my hand's covering it up, but I do want to just give some pressure on the top. That's sunk in there quite nicely actually. They're not fully recessed in, but they're most of the way in. So we'll let them cool. We'll take these screws out later. They're just temporary, we're just installing the nuts at the moment, but that looks good. Okay, so if we turn our attention back to the main part, we can now put some grease around here and install the ball bearings. I'm using this silicone clear grease. I've got absolutely loads of it. I just seem to apply it with my finger. It does get a little messy. So these are 6mm ball bearings, I believe. And just literally stick them on to the grease. Okay, actually leave a little gap in the last one because if we try and force an extra ball in there, that would be too tight. So the next thing I've done is put some grease on the underside of this gear, and then we can now pop that down in here. I'm just rotating it a bit, and we'll add a bit more grease. I want to put a bit in here. So I'm just having to put a little bit of pressure on the gear because otherwise it will ride up and come out. I'm just running it in one direction to just drag the grease around all the teeth of the gears. I'm fairly happy with that. So I think we'll just turn that off. So I'm just fixing the lid on with these 3/4 inch screws. They're number 4 by 3/4 inch. I believe that's 2.9mm by 19mm. I drilled out the holes in the top cover to 3mm so that they're clearance for these screws. So these are just tapping into the main part. There is a small gap in here. I'm actually not going to close it right up because I think that will put pressure on that worm gear. We'll just try it one more time to make sure everything's still okay. So I think that's okay. So I guess the next thing is to install the potentiometer. I'm just going to have a quick think about that because we probably want to stop the gear in a certain position. So with the Arduino commanding the servo to position 90, I can just control the position of the gear with the potentiometer. As I turn it one way, the gear turns one way, and as I turn it the other, the gear turns the other way. Now I'm just looking at this to try to determine if we need to reverse the polarity of the wires. I'm building the right shoulder. So if I set that so that the piece that's going, so you see you've got this solid piece that's kind of tracking around, that's going to actually have the potentiometer shaft stuck into it down in that little rectangular slot down there. I'm just going to move that so that it's hidden behind this piece, and I'm going to try and stop it when it's exactly behind it. So it's going out of sight, so I'll stop it there. If you have a quick look at the back, it's not 100% lined up, but it's fairly close. We're probably going to want to make fine adjustments on this anyway, and I'm almost 99% certain I'm not doing this right. What I'm looking at is, as I turn this potentiometer in one direction, I would expect to see the little slot down in there turn in the opposite direction, so it's resisting me, so it's resisting change. Because if the servo was in a position and we tried to turn its shaft, it should fight against us and try and hold its position. And as I'm turning this, that's going to be pushed down in there like that. So as I'm turning this, I'm going to turn the top in that direction, and I'm seeing the slot move in the same direction. I don't know if you can see that. And I was expecting it to be resisting me, so I think we need to reverse the wires. So I'm going to move that back to the middle. So I'm trying to explain it best I can. If it's not resisting us, if it's working and going in the same direction as us, it's just going to continue moving in that direction forever, and it's never going to correct the potentiometer's position. It's going to continue moving forever. It's going to reach the end, and it's going to possibly smash the potentiometer off when it hits the end. So I think it should be resisting us. So I'm going to reverse these wires. The red and the black, I'm going to swap them over. Okay, so with this wire swapped over, it is now resisting my movements. It's working in the opposite direction to what I'm turning the pot, and I think that's what we want. I'll position that back into the middle again, and I'll stop it. So I've got a couple of options now. I can either push that in straight up, or I can turn it over and push it in that way around, and I'm really not sure how we're supposed to position this potentiometer. So I'm probably going to have to change this later if this is wrong. So I can see it is working, I'm just not sure where to position it. Okay, so I'm using these little screws that come with the MG995 servos, I believe, the standard size servos that we used in the forearm. I believe that's the servo that these come from. They're a nice little screw, and they have a washer on the top, which is quite handy for securing the potentiometer in here. So I've fitted 2 of those, and they're just trapping it underneath their washers. One problem is they're a little bit too long, so I'm going to have to file off the bit that's protruding through. So I've just filed them down flat, so they're nice and smooth. Bearing in mind it's in position 90, more or less. It's slightly off, I know it is. I'm going to put that in there with the tails coming down towards the servo. I'm sure it's wrong. We'll just have to change it later when we figure it out. We need to make sure it does go right down into the little hole. Sorry, my hands are in the way. And then I'm going to rotate it around 90 degrees. So it's either now in position 0 or 180. And in theory, if I power it on, it's going to try and move itself back to position 90. So we'll see what happens. So it has moved it 90 degrees. So I think what I'm going to do is just secure that in there with a 3rd screw. And like I said before, we've probably got this wrong. We'll probably have to make some changes a bit later. And for that 3rd screw, I actually introduced another washer that was a bit bigger because it felt like the screw was too far away from the inner circular piece. So I believe how this is going to move is this is position 90, so it's either going to be 0 here or 180 here, and then vice versa, it will be 0 here or 180 here. I think it's going to swing around the bottom half. This section we can see in there, I think it's going to swing from this side around to that side, but I'm not sure which is 0 and which is 180. So we can set up a sketch to test that, to find out which is which. And then there's a question of, is it supposed to swing around an arc like that, or is it supposed to swing from the position it's in now around to the top position there? I really don't understand how that goes together, so we're just going to have to wing it and discover it as we go along. So I can at least see that when you command it to a certain position, it will move to that position. It's just a question of exactly how we set things up. So I'm happy with that. We've got a basic working gearbox. The video is getting a bit long, so we will leave it there. We'll come back in the next video and we'll build up the assembly on top of here and add in another servo. So as always, if you liked the video and you want to see more of these, please give it a thumbs up. If you haven't done so already, please subscribe to the channel. I really want to see some more subscribers. Thanks for watching, and I'll see you next time.